talk given by Shrikant, and the title is AutoDub, Automatic Redubbing for Voiceover Editing.
Thank you. Hello everyone. The topic of our presentation today is AutoDub, Automatic Redubbing for Voiceover Editing. The other day I was trying to record a few lines for my demo video for UIST, and I had a recording that sounded like this. Recording narration tracks for demo videos and podcasts can be frustrating. Small spoken mistakes often necessitate either re-recording the narration multiple times until it is error-free, or audio editing to add, remove, and replace words. In this Sky paper submission, we will demonstrate an alternative to this workflow that allows us to seamlessly correct such errors. We will demonstrate a system in which a user will only need to record small snippets with the correct content, and it will automatically replace the errors in the original recording. So when we have a recording like this, there are really two ways to deal with it. The first option is to re-record the entire thing, but that would be too much work when we're really dealing with long recordings and long narration tracks. And if you're someone who's very sloppy like me, you might even mess up the whole recording once again. So the smarter option over here is to try to re-record only the mistakes and somehow do a little bit of audio editing to replace the mistake by the new recording. So what we would really like to have is replace this mistake in this Sky paper submission by a new recording that sounds like this. In this UIST paper submission. But if you're not someone who's an expert at audio editing, this would give rise to a couple of new problems. So now that we have these two recordings with us, what we really don't know is where to really place this new recording in, and the second problem is how do we really do that? If we look at the way an expert tries to solve this problem, we see that the expert first tries to identify the location of the error, and once the location of the replacement has been identified, the expert then tries to open something called a multi-track session and then does crossfades and a lot of other things. My point is there is a lot of clicking involved, there's a lot of opening of windows, and this is a process that requires a lot of domain expertise, and this could be tedious and prohibitively difficult for novice users. So what we really need at the moment is a strategy to make audio processing and audio editing more accessible, and one possible way of doing that is to try to automate the underlying processes involved. So when we do that, that would really simplify a lot of interactions, and for example, in the case of redubbing, we could try to automatically locate the error and automatically crossfade it in. So in the case of AutoDub, we used a very popular algorithm called dynamic time warping to automatically locate the error. So we see that when we apply dynamic time warping on these two recordings, it automatically returns us the position of the replacement, and once we know where to replace, we can automatically crossfade it in. So over here, let's try to understand a little bit more about how dynamic time warping really works. Let's say we are given two sequences, sequence 1 and sequence 2, and sequence 2 is really a stretched or a compressed version of sequence 1. So when we apply dynamic time warping on these sequences, we see that the warping path maps every element of sequence 1 to a corresponding matching element in sequence 2. Now an extension to this is the subsequence DTW, where sequence 2 is a much longer sequence, but we know that sequence 1 appears somewhere in the middle of sequence 2. So when we apply DTW on these two sequences now, DTW again maps every element of sequence 1 to its closest element in sequence 2, but interestingly, we also get the position of sequence 1 in sequence 2 by the DTW warping path. So in the case of AutoDub, we try a new extension to this, where we say that we know sequence 1 appears somewhere in the middle of sequence 2, but this time it appears with a small modification in the middle. So when we apply DTW on these two sequences, we again see that DTW is able to correctly locate the position of the sequence, even though there is an error. But in this case, what DTW is really trying to do is it is trying to rely on the available context on either side of the error. So in the case of AutoDub, over informal experiments, we have seen that an error of n seconds really requires a context of n seconds on either side of the error. So, but that's not a very stringent requirement, because when we record overdubs, they are always rounded off to the nearest stop or a comma anyway. So if we check out the results that we now have something like this.
Recording narration tracks for demo videos and podcasts can be frustrating. Small spoken mistakes often necessitate either re-recording the narration multiple times until it is error-free,
or audio editing to add, remove, and replace words. In this UIST paper submission, we will demonstrate an alternative to this workflow that allows us to seamlessly correct such errors.
We will demonstrate a system in which a user will only need to record small snippets with the correct content, and it will automatically replace the errors in the original recording.
Well, the squeaky thing wasn't really AutoDub's fault, that was mine. Anyway, the thing is we can also do deletions using AutoDub. For example, let's try to delete the that we had at the end of the earlier recording. So all we need to do now is to re-record the sentence correctly.
And it will automatically replace the errors in the original recording.
And if we give these two recordings to AutoDub, we get an output that sounds like this.
Recording narration tracks for demo videos in podcasts can be frustrating. Small spoken mistakes often necessitate either re-recording the narration multiple times until it is error-free, or audio editing to add, remove, and replace words. In this waste paper submission, we will demonstrate an alternative to this workflow that allows us to seamlessly correct such errors. We will demonstrate a system in which a user will only need to record
small snippets with the correct content, and it will automatically replace the errors in the original recording.
Now the interesting thing is we can also use this to make small additions to the narration track. Let's try to add a word tedious over here.
Or tedious audio editing to add, remove, and replace words.
Now if we give AutoDub these two recordings, we get a narration track that sounds like this.
Recording narration tracks for demo videos in podcasts can be frustrating. Small spoken mistakes often necessitate either re-recording the narration multiple times until it is error-free,
Or tedious audio editing to add, remove, and replace words.
In this waste paper submission, we will demonstrate an alternative to this workflow.
Anyway, to understand how AutoDub really helps in the redubbing process, we performed a simple user study where we tried to compare AutoDub with the manual redub completion time. So we do that by comparing the completion time of AutoDub with the average expert manual completion time, which is really shown in the figure by these black lines. So we see that as the complexity of the redubbing task increases, that is, as the length of the narration track increases, experts really need a lot longer than AutoDub to complete the redubbing procedure, and this really means that AutoDub enables faster redubbing capabilities. But the interesting thing to note here is that AutoDub now allows novice users to complete a redubbing procedure, which was something earlier completely infeasible, and in fact novices can now complete the procedure in the same time as an expert. Now this actually points to the easier redubbing capabilities that AutoDub enables, and this can also be seen by the fact that the user satisfaction scores are unanimously positive for AutoDub, while the satisfaction scores are really negative for the manual procedure. So in summary, in this paper we presented AutoDub, which was a simplified version of the redubbing workflow, and this was obtained by automating a lot of the underlying processes involved. And now redubbing can be done equally easily by novices and experts. To do this, AutoDub really relies on a novel application of dynamic time warping, where we try to use the context on either side of the error and do the replacement automatically. But to talk about this on a higher level, we see that audio editing can be a prohibitively difficult task because it requires a lot of domain expertise. So one way to simplify the interactions involved would be to provide automated functions which would essentially enable accessible editing for novice users and also a faster processing strategy for experts. Thank you very much.
I know the break is coming. Well, nice work. I mean, certainly have had the issue of re-recording things too many times when we do this Chi and UIST videos.
I'm glad you had that. Now we can have a paper out of it.
So the thing that happens to me is oftentimes I realize I stumbled on the word and I just stop. And so I guess the question is how tolerant it is to really messing up big time a part and then trying to replace it. How good is it finding the match?
Could you elaborate on that when you stumble on a word and you stop?
Well, I have my stuff, I start talking, and then I realize I got it all wrong, and I stop and restart the sentence, for example. And so it's more like just, the examples you showed here that were small words added or coughing or something.
Yeah. So even if you have stops in between, if you have sufficient context on either side of the sentence, AutoDub is pretty robust. So in the paper, we talk about some experimentations that we did, and we saw that in all the cases, if we have sufficient context, AutoDub is able to do the replacement perfectly. So I would say it is extremely robust to all these modifications.
Okay, and so is this going to be available for? General audience?
The plan is to launch this in probably soon, but we don't know
Okay.
yet as of now.
Okay. Thank you very much.
Thank you.